Before we start day 4, let's talk a little bit about day 3.py, which is my solution to day 3's exercise. The first thing I did was I segmented the whole calculator user flow into 3 big steps. So I first print out the instructions using a function that we've defined, and then I've asked the input from the user, returning 3 different values in choice, number 1 and number 2. And then we finally calculated the results and printed it out using choice number 1 and number 2's values. Let's look at these functions one by one. Print instructions are very simple. We're simply calling 5 print functions to print out our instructions for us. Ask input is again similar. We use 3 input statements to ask the user for inputs, and we are asking the questions that we've seen on screen before, and we're simply storing these 3 inputs from the users into choice, num1 and num2, and we're returning this as the function return so that we can leverage it in the main function bits. The last function is calculate, so we need to see what the value of choice is. So if choice is 1, then we call an addition function. If choice is 2, we call a subtraction function, so on and so forth. I've also added this else statement here to catch any choice that's not 1 to 4, and it simply tells the user that this is an invalid input. In each of the addition, subtraction, multiplication, and division functions, all we're doing is taking number 1 and number 2 and applying the mathematical operator between the two to create the results. For example, here in the addition function where the result is number 1 plus number 2, and we print out number 1 plus number 2 equals results. The same thing is done with subtract, multiply, and divide. Again, I need to stress that this is one way to do all of this. I have segmented the bigger functions into smaller functions. I've named things all according to my personal coding style. If I was in a team, I would have applied to the team's coding style, but the core requirement here is for us to create the behavior we need that runs in a reasonable time. So now let us begin day 4's exercises and program.
We're in a new day, day 4, where we understand lists and dictionary data types in more depth. In this section, we're going to take a look at lists and dictionaries. So we're going to split this into 4 videos. We're going to introduce lists, talk about list operators, functions, and methods, introducing the dictionary data type again, and then also look at dictionary operators, functions, and methods. So we've already looked at a very basic list, right, in the beginning of this course and also just now in the loops section. Now I want to give you a more in-depth view of lists, what they can do, what they are for, etc., and hopefully build up good fundamentals of how you interact with this data type in Python. We're back in our IPython, and as you know, a very basic list is something like 1, 2, where you declare a list by opening a square bracket, putting a bunch of elements in, and closing the square bracket, and that's how you get a list of things. So in a list in Python, it doesn't need to have elements of the same type, so we can have one string and then like a flow, right? No problem. You can have nested lists, so you can put one list inside another, so you can have 1, 2, no problem. And if we look at the type, so we have nested list type nested list 0. We'll see that is also a list. That's a string and that's a float. To access the elements of a nested list, we need to do 2 index operations instead of 1. So we have nested list 0 and then 0 gives us the first element of the nested list inside the first element of nested list. Similarly, we can do nested list 0, 1, 2 indexes. If you think about it, what this is saying is actually nested list returns the list, which is this guy, okay? And then if we index it by 0, it gives us this guy, which is also a list. And then so Python has actually replaced this variable indexed at 0 with just this value. And then we can index it again at 1 to get the element, the second element in this list, which is 2. And that's all there is to it. So the basics of lists is very simple, which is why we spent just a few minutes on this. But then the real power of lists is when we use different list operations to extend and transform the list. And also, as we've seen before, after we've transformed these lists or create a new list, that's a very powerful way to then feed into a for loop or a while loop that operates on lists with even more complexity.